What causes internal combustion engine problems? Imagine a finely tuned machine that turns fuel into motion. Now picture that machine facing hurdles that slow it down or cause it to stall. That's what happens when internal combustion engines run into trouble. These engines are at the heart of many vehicles, converting chemical energy from fuel into mechanical work through controlled explosions inside cylinders. But problems can pop up from several sources, disrupting this process and making the engine less efficient or even causing it to break down. One common issue is imperfect combustion. For combustion to be efficient, the air and fuel mixture must be just right, and the ignition timing needs to be spot on. If the mixture is too rich or too lean, or if sparks ignite too early or too late, combustion becomes incomplete. This results in less power, more emissions, and sometimes knocking sounds that can damage the engine over time. Think of it as trying to light a fire with damp wood, it just doesn't burn properly. Gas exchange inefficiencies are another culprit. Engines depend on intake valves to bring in fresh air and exhaust valves to remove burnt gases. If these valves leak or open and close at the wrong times, the engine can't breathe properly. This means less oxygen for combustion and leftover gases that dilute the mixture, reducing pressure inside the cylinders. It's like trying to blow up a balloon with a hole in it, the pressure drops, and the balloon won't expand as much. Heat transfer losses also play a role. When fuel burns, it produces heat that should turn into mechanical energy. But some of that heat escapes through engine parts or the cooling system. Excessive heat loss means less energy is available to move the pistons, lowering the engine's thermal efficiency. It's similar to trying to run in a cold room. Your body has to work harder to stay warm, just like the engine loses energy through heat. Mechanical wear and leaks are inevitable over time. Piston rings and cylinder walls can wear down, causing blow-by where gases leak past the piston into the crankcase. This leak reduces pressure inside the cylinder, cutting down power. Damaged valves or seals can also cause compression loss, which messes with the thermodynamic cycle that makes the engine work. Think of it as a leaky water pipe. Less water gets through, and the flow slows down. Fuel quality and air purity matter too. Using poor quality fuel or air contaminated with dust or moisture can alter combustion temperatures and pressures. This can lead to deposits forming on engine parts, which further hampers performance. It's like trying to cook with spoiled ingredients. The dish doesn't turn out right. Cold starts are particularly tricky for some engines like diesels. These engines relying on high compression temperatures to ignite fuel. When it's cold outside, the engine struggles to reach that temperature, making starting difficult and causing incomplete combustion until it warms up. It's like trying to light a fire in damp weather. It takes longer and might not burn well. All these issues mean the engine can't efficiently convert fuel into motion. Power drops, fuel consumption rises, and emissions increase. Fixing these problems involves checking the quality of the combustion process, inspecting valves and pistons for wear, ensuring fuel and air are clean, and managing engine temperature properly. Understanding how these problems relate to the principles of thermodynamics, pressure, temperature, and flow inside the cylinders helps us see why maintaining these systems is so important. Keeping everything in good shape ensures the engine runs smoothly, efficiently, and reliably.